Hey kids, how are you? I'm here today, but not here as always, but here behind the camera. Why? Because this topic, the electron transport chain, deserves its own video. So just forget about me and listen to what I have to tell you. This, my friends, is one of those things that normally people don't realize how important it is until it gets into the test. So this, my friends, very important. Second thing you need to remember, this. What is this? This is actually hydrogen. I'm just going to put it here, plunk, because as you know, NAD is a carrier, is an enzyme that grabs hydrogen and carries around. After the Krebs cycle, it grabs it and whoop, comes here. Now, what is this? This is hydrogen. But hydrogen is not just simply hydrogen. Hydrogen has a very important role and has a very important characteristic that nothing else in this universe has. It is the smallest and it has one proton, one electron. That is going to become very important because our bodies, our mitochondria, discover a way to just, they don't break down this, but they use this capacity, this ability to make something like this. NADH releases hydrogen. You see that hydrogen goes out? Well, actually, it's not hydrogen that goes out. It's only the proton of the hydrogen. In this case, two. Two hydrogens provide two protons. So I'm going to make this move out, this hydrogen move out. But Mr. Christian, it says hydrogen, it says two hydrogen. Yeah, but you know that I'm going to use two of these and two are going to go out. So now I have two protons out. Remember that. Also, my body is so intelligent that it will make this what? Hydrogen, Mr. Chris. No, it's not. Because now it's only the electron. If I have the proton out, right? This is the rest of that. And it's the electron. This is the importance, the beauty of this. You know which one is it? Because our bodies, our mitochondria discovered a way of dissociating this hydrogen in order to put it where it's needed to synthesize ATP. So I'm just going to go fast because you know these videos have to be fast. So remember, I take this. So this will jump from complex 1 to complex 2. Bang. Okay? So I have simple molecule. It's charged. And then it's discharged. What it's going to do? This is going to make it move to coenzyme Q. What is coenzyme Q? Coenzyme Q is something that grabs, accumulates my electron and makes it move from side to side. Remember, we are here. So, next impulse. Pop. Coenzyme 3 or cofactor 3 or enzyme number 3 or complex 3. What is complex 3? Is another enzyme that will do the same process again. I have two hydrogens here, right? I have two hydrogens and I make exactly the same as I did before. Pull them out. All the electrons move along the way, right? The protons are out. Now I have more protons out. If you notice, we are creating something. I won't tell you because I need you to think what we are think about what we are creating in this process. Then our electron jumps here, and this is beautiful because this is the last step of the road. Our electrons cannot stay here any longer. If I leave them here, I'm just going to break down the first law of thermodynamics. What I need to do is just pull them out. How do I pull them out? Well, I use them as energy. Energy for what? Energy to synthesize. To synthesize what? Half hydrogen that I have, half oxygen molecule that I have here, plus the electron here, will create, plus the hydrogen, will create water. Also, I still kick out some of the protons. Now, I have 2 hydrogen protons here, plus 4, hydrogen protons here, plus 2 here. I have total 8. How many do I have inside the matrix? None, because all of these already left. Remember? All of these already left. So my potential is out there. What I'm creating is a gradient. Very good. So we're creating a gradient, a proton gradient, a proton pump, if you will, outside. Because one of the first laws of nature tells us that all energy will flow from somewhere with higher concentration to lower concentration, and then I have this higher concentration, then it's going to move to an area of lower concentration, so it's going to circulate. Now, if you notice, this will go out, and then accumulate and come in back again. It's free. It doesn't use any ATP. And the beauty of this is that I'm going to use this 5 here. It's actually not 5 because it's not even a complex. This is an enzyme itself. The name of this, ATP synthase. ATP synthase. What is this? This is actually a pump. And this only allows hydrogen protons to come back in. When they come back in, they charge this. Why do I need this to be charged? Because I have ADP from previous processes plus phosphate. This energy, clank, closes this and will create ATP. Plus the water that I have here. This is the result. This is the actual result of our electron transport chain. Not only this will provide the highest yield of ATP in the whole respiratory process. We will yield from 32 to 34 ATPs in this way. Also, some authors say it's not 32. Sometimes it's 34. Sometimes when it's very high yield, it's 36. Sometimes it's lower. But if you notice, we are multiplying 7-fold what we had before. So, my friends, this was the video for today. Next video, Krebs cycle and all the outcomes. Not only the Krebs cycle, we're going to see the Krebs cycle and glycolysis and electron transport change. It's going to be a big summary of what we need about this. See you later. Bye.